Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to see change of scale property and we'll also solve some problems, examples on change of scale. So let's get going. Change of scale property says that if L of f of t equal to f of s, then L of f of a t equal to 1 by a f of s by a. Okay. Let L of f of t equal to f of s, right? Which is integral 0 to infinity e power minus st f of t into dt, right? Now coming to L of f of at. Okay, so we can write this as integral 0 to infinity e power minus st into this function f of at into dt. We are just applying this formula. Okay, in place of t we'll have at, that's it, or we'll just write f of t here. Okay, this equals to, let this at be some x, let at equal to x, then t equal to x by a. If t equal to 0 or when t equal to 0, just apply t equal to 0 here, then you'll get x equal to 0. If t equal to infinity, then apply t equal to infinity, then you'll get a into infinity, which is infinity, then you'll get x equal to infinity, right? Now differentiate on both sides with respect to x. You'll get dt by dt, or derivative of t with respect to t is 1 equal to, you can write this as 1 by a into d by dt of x, which gives us 1 equal to 1 by a into dx by dt, or it's dt, okay, or dt equal to 1 by a into dx, right? Now this becomes 0 to infinity e power minus s into, we can replace this t by x by a into f of at can be replaced by x and dt can be replaced by 1 by a into dx. Here 1 by a is constant, so let's write it outside the integral. You'll get 1 by a integral 0 to infinity e power minus s by a into x into f of x into dx, right? Since we know that integral 0 to infinity e power minus st into f of t dt equal to f of s, right? Then integral 0 to infinity into e power minus pt into f of t dt will be f of p, right? Or integral 0 to infinity e power minus px into f of x dx will be again f of p, right? So let s by a equal to some p, then this becomes 1 by a integral 0 to infinity e power minus px into f of x dx, which is the formula of Laplace transform of f of x, that is f of p, capital F of t we can say, right? Since p equal to s by a, let's replace this p by s by a, then you'll get f of s by a, that is 1 by a into f of s by a. Therefore L of f of at equal to 1 by a into f of s by a. Right? This completes the property. Now let's see some examples on it. Okay. First one, we need to find Laplace transform of sin h to t. Okay. Firstly, we'll find sin ht, which is equal to 1 by s square minus 1 square. 1 by s square minus 1, right? Since L of sin h at equal to a by s square minus a square. Okay. Now coming to L of sin h 2t. This is equal to, here we are having 2t, right? Just compare sin h 2t with L of f of at, that is for a equal to 2, you will get 1 by 2 into f of s by 2. Okay, we'll just apply this formula. Okay, this is equals to 1 by 2 into, so this is our f of s, right? If f of s equal to 1 by s square minus 1, then f of s by 2 will be 1 by s by 2 whole square minus 1, right? So you'll get 1 by 2 into f of s by 2 is 1 by s by 2 whole square minus 1, which gives us 1 by 2 into 1 by s square by 2 square is 4 minus 1. We can write this as 1 by 2 into 1 by s square minus 4 by 4, or we can write this as 1 by 2 into 4 by s square minus 4, which is 2 by s square minus 4. So when we are asked to find L of sin h 2t using change of scale property, this will be the procedure. Or if you are not asked any particular property, or if you are not asked to find without mentioning the formula or property, you can just apply this directly. Okay, so you'll get 2 by s square minus 2 square, which is 4. You'll get directly. Okay, fine. Therefore L of sin h 2t equal to 2 by s square minus 4. Now coming to the second example. Find Laplace transform of e power 2t using change of scale property. Firstly, we'll find L of e power t. Since we know that L of e power at equal to 1 by s minus a, right? So this gives us 1 by s minus 1. Okay, which is our f of s. Let's now find L of e power 2t. Right? Here our a is 2. Just compare L of f of at with L of e power 2t. For at equal to 2t, we'll get a equal to 2. So we need to find, okay, we'll apply this formula. You'll get 1 by 2 into f of s by 2 here. We have just applied this formula for at equal to 2t. If L of f of t equal to f of s, then L of f of at equal to 1 by a into f of s by a. If f of s equal to 1 by s minus 1, then f of s by 2 will be 1 by s by 2 minus 1, right? So here you'll get 1 by 2 into f of s by 2 is 1 by s by 2 minus 1, which gives us 1 by 2 into 1 by s minus 2 by 2, or we can write this as 1 by 2 into 2 by s minus 2, where 2 gets cancelled, you'll get 1 by s minus 2. Okay, since we are asked to find Laplace transform of e power 2t using change of scale property, so we have applied this. Or if you are not mentioned any property, just use this formula. Then also you'll get the same thing. L of e power 2t is 1 by s minus 2 for a equal to 2. Right? Fine. So we have seen change of scale property with some examples in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.